So we have a related rates problem. A street light on top of a 12-foot pole, a 6-foot tall woman walking away at a speed of 4 feet per second. Okay. And how fast is the shadow moving? So here's the pole, 12 feet high. Here's the woman, 6 feet high, 6 feet tall. And there's the light beam from the top of the pole. And then here's the shadow that the woman makes. Okay, so let's see what happens as she moves. Okay, first of all, let's label things. I'm going to call this distance x1 and this distance x2, or let's back it up a bit. Okay, so the distance of the lady from the pole is going to be called x1, and the length of the shadow is going to be x2. Okay, so as she walks, the shadow lengthens. All right. So that's what's happening here. The distance, as the distance from the pole increases, the length of the shadow increases. Okay. So let's see, related rates. Okay. First thing to notice is that we have similar triangles. So we have a big triangle there and a smaller triangle, which is similar. Okay, so the ratio of the sides is all, so big to small is going to be 2 to 1, 12 to 6. Okay, so we can set up from this triangle, the two triangles, we can set up a relationship here. Let's just pause it and understand this. So the total length, x1 plus x2, divided by the length of the small triangle, is going to be the same ratio as the length, the height of the pole to the height of the woman. So 12 over 6. Those ratios are going to be equal. Okay. So that's 2 on the right side, and then we're going to multiply by x2. So we end up with that. And I want the x1s on one side, x2s on the other. So we have x1 equals x2. All right. For the rates, we differentiate each side. All right. And so we know, let's just pause it here. Dx1 dt is the rate that she's moving away from the pole, the rate that she's walking. That's here. This is the rate of change of the length of the shadow. Okay. So we know her speed is 4 feet per second. And that means that the length of the shadow is the same. The rate of change is the same. Now you notice here that it doesn't matter what the actual distance is. The question specified when she's 40 feet from the pole, what will the rate of change be of the shadow? And you notice it does not depend on x1 at all. So it's always equal to 4 feet per second. Okay. Hope that was helpful.